Hi there and welcome to lesson 10.1b. In this video, we will be focusing on the distance formula. This is the distance formula. It's used to find the distance between any 2 points on the coordinate plane. Take a moment to pause the video so that you can write this formula in your notes. All right, now that you've written it in your notes, let's take a look and see if we can try it. Suppose you're given 2 points and they're -2, 1 and 1, 5. And you're asked how many units apart are they on the coordinate plane. There's two ways that you can do this. You could first use Pythagorean theorem, but then you also could use the distance formula. So we're going to do them side by side so that you can see how similar they actually are. Okay, let's begin by just plotting those 2 points on the coordinate plane. -2, 1 and 1, 5 would look just like this. So do you see how if I connect the 2 points, they're diagonal from each other. So I just can't count the number of units apart that they are. But I could use the Pythagorean theorem if I make a right triangle out of them. So just by drawing a horizontal and a vertical line here and here, I can then make a triangle that has a right angle. And I know that across the bottom, it has a length of 3 units, and then vertically, it has a length of 4 units. And so when I'm finding this diagonal unknown side, which is the distance between those 2 points, it's really side C. So if I just go over to the Pythagorean theorem here, I can figure out the length of side C. A and B would be 3 and 4. And then in the calculator, 3 squared plus 4 squared, that's 9 plus 16 is 25. And of course, the length of C is not 25, that's C squared. So I still have to undo the exponent, the squared, with the square root. Those two are opposites and they will cancel each other. So I do the square root to the other side as well, and 5 units would be the length of side C. So this would be using Pythagorean theorem in order to figure it out. Now you could do that, or you could use the distance formula, and that's what I'm going to show you next here. So again, if I want to find the distance here, it's this diagonal length. And I know the 2 points that are given above, and we're going to need those 2 points in order to plug them into the distance formula. Because you see here how I'm going to be subtracting the x values, and then I'm subtracting the y values. And now you see this is x sub 2 and y and x sub 1. Remember, that's x from the second point, x from the first point. And then the y sub 2 and y sub 1, that's y from the second point and y from the first point. You probably recognize this from the slope formula. Remember how you were subtracting the y's and then you were subtracting the x's and you saw that same sort of notation? Yes. And remember, it didn't matter the order that you were subtracting. And same thing with distance formula. It doesn't matter the order that you do that as long as you are consistent. Okay. So of course I see this is x, this is y. And this is x, this is y. It doesn't matter which one's the first point or which one's the second point. Okay, so let's try this. Distance equals, and I want square root. Now I want to follow order of operations here. So I'm just going to first fill in what I know here. I'm going to be taking the x's and subtracting them. So here I have an x, and here I have an x, and I'm just going to go left to right. -2 minus 1. Okay, remember there's an exponent on there, so I'm going to put the little exponent there, and then I'm going to bring down the plus sign, and then another subtraction here. I'm going to subtract now the y's. So because I did left minus right, I'm going to do the same thing for the y. So here's the y, this is 1, and then I'm going to subtract 5, left to right. 1 minus 5, and then that's to the second power. Okay, so now I have to follow order of operations. Inside the square root or the radical, I first would want to do parentheses, then exponent, then add. So in parentheses, I have -2 minus 1, that's -3. Okay, and then I'm going to do the other parentheses. 1 minus 5 is -4. Okay, so I still have the radical symbol. Don't forget to bring that down. Now I do exponent next. -3 times -3, that's -3 squared, that's going to give me 9. So this is always going to be a positive number because no matter if this is positive or negative, if you square it, it will be positive, okay? And then plus, and then here when I take the -4 and square it, -4 times -4 is 16. And then I want to add them together. 9 plus 16 is 25. And the last thing would be the square root of 25, which is 5. And so the distance between the 2 points would be 5 units. Now notice we get the exact same answer with Pythagorean theorem. And if you take a look through the work that we've showed, you're going to see how similar all of the numbers were. Very similar to Pythagorean theorem. Of course, it just looks like a little bit more work or more steps. Okay. So there are some cases where distance formula is better to use than Pythagorean theorem. You can't always make a triangle if you have no coordinate plane, okay? So there are some cases when one is easier than the other, but both of them will ultimately get you the exact same answer, okay? So there they are side by side. All right, let's try this again. Here we're asked to find the distance between points A and B, and we're asked to use the distance formula. Oop. I gotta get my marker here. So distance between points A and B. Now I could connect them and make a right triangle, but I'm not going to because I'm being asked to use the distance formula to find the distance. So this is good just to practice this formula, okay? So if I'm going to use the distance formula, I have to know what the points are. So I'm gonna go over here to the points and I'm just going to Okay, we had a little announcement in there. No sixth grade meeting. Good to know. Okay, so the point here for B would be 1, 2. And then the point for A, we would name that -4. Oop, it doesn't really look like a 4. And then that -1. So we want to name the points because you have to have the X and the Y values to plug them into the distance formula. Okay, so I'm just going to switch out the color here. We'll make this black. There we go. Okay. So I want to subtract the x's. And you have to do that the same, like left to right or right to left, but it has to be consistent. So I'm going to go left to right. So I'm going to go -4, subtract 1. And then that's squared, plus. Now I'm going to subtract the y coordinates. So I'm going -1, subtract 2. And then that's squared. Okay, so let's bring down the square root, the radical. I want to do parentheses first. So -4 minus 1 is -5. And then -1 minus 2 is -3. Okay, bring down the square root or the radical sign. Now -5 squared. -5 times -5 is 25. And -3 times -3 is 9. Okay, then I can add those two together. 25 plus 9 is 34. So now here the answer is the square root of 34. That would be the exact distance from A to B. However, I could use my calculator and like approximate it like to the nearest tenth. But if you look at your answer choices, answer D is exactly the square root of 34. So that is the distance between the two points on the coordinate plane. And we use the distance formula to figure that out. Okay, let's see what we're asked to do in number 3. The endpoints of line AB are given here, 5, 1, and -6, -5. And the endpoints of line CD are also given. How much longer is AB than CD? Now, this sounds like a pretty complicated problem until we start to graph this out so we get more of a visual. So those of you that are visual people, let's plot these points. So the endpoints of AB are 5, 1, and -6, -5. So there we can connect that line together. Okay. Then the endpoints of CD are -6, 5, and 3, 5. And we can connect those two together. So what I did was I just graphed these ordered pairs, these 4 ordered pairs on the coordinate plane so that I can get a little visual of what's going on here. Now the question's asking us how much longer is AB than CD? And we can definitely see that AB is longer, but we want to know how much longer. So we're going to have to figure out the lengths of both of them, and then we're going to have to find the difference by subtracting. Okay, well, if you look at CD, this is just as simple as counting up how many units long it is, because it's just a straight line. So I could count 1, 2, 3, 4, 5, 6, 7, 8, 9. This has a length of 9 units long. Okay, so I've got CD. Then what I can do is find the distance between A and B by using the distance formula. Okay, so I know that AB were these ordered pairs right up here. And I mean, if it helps you, I could write them here. You can also write them on your graph. 5, 1, and -6, -5. Okay, so let's use the distance formula since we're practicing that in this lesson. Okay, so distance equals square root, and I've got it right over here to the left, so you can see that we want to subtract the x's. So I'm going to go over to my picture, and I got -6, subtract 5. I did left to right, squared, plus. Okay, and now I want to subtract the y's. So I got -5, subtract 1. All right. So in parentheses here, -6 minus 5 is -11. And then I have -5 minus 1 is -6. Then I take -11 squared. -11 times -11 is a positive 121. You're always going to get a positive number here. And same thing here, -6 squared is -6 times -6. You will always get a positive number here. Then when you add those two together, 121 plus 36 is 157, which is not an exact amount. So let's type square root of 157 into the calculator and go out to the tens place, and this is 12.5. Okay, so that means that this is a distance of about 12.5 units. Now the question is asking us how much longer. So in order to figure out how much longer, I'm going to have to use subtraction. So I'm going to take the longer one, and I thought I changed colors. It's like, no, you didn't. There we go. Okay, so I'm going to take the longer one, which is 12.5, and subtract the shorter one, which is 9, and that's going to give me 3.5 units longer. So I'm just finding the length of both of them and then subtracting. And I used the distance formula for the diagonal line. There we go. And that's how you do a problem like that. And you could use Pythagorean theorem, I suppose, too. You could have made a right triangle out of this one, but I wanted just to practice the distance formula. Okay. On the last one here, number 4. Here our problem states Lauren traveled from -1.53 on the coordinate plane to 7, -3.5. And then from there, she went to -5, 2.5. Now we see some decimals in there, right? Now we're asked for the total distance that she traveled. So we want total distance. So I'm just going to circle that to keep in mind. Now when we're finding the total of anything, we're going to be adding. Okay, so we will be adding, unlike last when we were subtracting. All right, so we've got two different distances going on here. Just to give you visual learners, just a little picture of what's happening. So on the coordinate plane, this is the start at -1.5, 3. She starts there and she goes all the way over to 7, -3.5. Then it says from there, she goes to -5, 2.5. And we're asked for the total distance that she traveled. So if you think about this, how many times are we going to have to use the distance formula? Twice, right? 2 times. And then we're going to have to add them together. Okay, so let's begin. I'm going to change the color to red. So we're going to find the first distance in red since I have my picture in red here. All right, so we're going to find from here to here using the distance formula. A calculator is really going to be helpful with this too. All right, so here's my square root. My x's, I got negative 1.5 minus 7. And then squared. Okay, then I'm going to subtract the y's. 3 minus negative 3.5. So 3 and then minus or subtract, and then I have negative 3.5. That double negative right here that you see, we should know that that's the same thing as adding, right? And then squared. Okay. So now I want to do parentheses first. And so I want negative 1.5 minus 7 in the calculator, and that's going to give me negative 8.5 squared. And then I've got 3 plus 3.5, because remember a minus a negative is adding, and that's going to give us 6.5 in the calculator. Okay, so then I'm going to take my calculator and do negative 8.5 to the second power, and that should give me a positive number because it's negative 8.5 times negative 8.5, and that's 72.25. And then 6.5 squared is 6.5 times 6.5, which is 42.25. Lastly, then I add these two together. And when you add them together, you get 114.5. So now I'm going to use the calculator to evaluate maybe out to the tenths place. Square root of 114.5 is approximately 10.7 units. Okay, so here I have the distance right here of 10.7 units. That's the distance in red. Okay, so that's all of my work in red. I'm going to delete that or erase that. And now I'm going to switch my color to blue so that you can see my work in blue, because that's my second step here. That's when I travel from this point to this point. Okay, so I'm going from right here and I'm going all the way to the end, which is right here. Okay, so I'm going to be finding the distance from, maybe you want to rewrite it, and that's from 7, negative 3.5, and I'm going to the location of negative 5, comma 2.5. So now I got to find this distance. All right, my final answer in blue, but I think just for sake of, we'll do in black. Okay, so distance equals square root. Get that off of there. All right, so now we want to take the x's, 7, subtract negative 5. Squared. Now we're going to subtract the y's. This is negative 3.5, subtract 2.5. And that's squared. Okay, so we've got to grab the calculator. Now, if you're using the scientific calculator on the MCA calculator, you should be able to type all of that in. I'm just going to kind of walk you through each step just in case you want to see like all of the steps here together. So this, I have 7 minus negative 5, which is 12 squared. And then negative 3.5 minus 2.5, that's going to be exactly 6 squared. This is working out nicely. 12 squared is 144. 6 squared is 36. So my last step would be to add them together, and 144 plus 36 is 180. And then if I type 100 square root of 180 in the calculator and round to the nearest tenth, it'd be 13.4 units long. Okay, so switching the color here, this distance is 13.4 units long. Now, erasing my work here, I want to find the total distance. So I'm going to have to add those two distances together to figure out how far total Lauren traveled. So I've got 10.7, oops, and that was right here. And then I've got 13.4, a little bit longer distance, that was right there. And then when I add them together, you end up with 24.1 units. And that was the total distance that Lauren traveled. So I'm finding distance using the distance formula twice and adding them together. It would be probably silly to do, you could do triangles, I suppose, but when you're trying to make triangles on this picture, it's going to get a little bit sloppy, as you saw there when I was trying to make triangles. So distance formulas, it can be really helpful. All right, so there we saw 4 examples where we're using the distance formula. Again, if you didn't get the entire distance formula into your notes, pause the video now and be sure that you write it down. Thank you for joining me. Have a great day.